Hi, welcome back to this video. Let's obtain the general solution of the equation x dy over dx plus y squared plus y is equal to 0. Let's obtain pala the particular solution by having initial condition of y sub 0 is equal to 1. Okay, so this is our differential equation x dy over dx plus y squared plus y is equal to 0. Okay, so separating the variables, we get x dy plus y squared plus y dx is equal to 0. Then dy all over y squared plus y plus dx all over x is equal to 0. And from here, you can now easily see that we have a separable equation by having terms of y's and terms of x. Okay. And after this, we may now integrate both sides. So integrate. So we have the integral of dy all over y squared plus y plus the integral of dx all over x equal to 0. So what technique can we use in order for us to integrate this part? As you can see here, we have a equivalent partial fractions here by saying using partial fractions. We have say we have the y1 all over y squared plus y is just equal to 1 all over y by y plus 1, right? So if we have this, we can now equate this with a all over the first term plus b all over the y plus 1. Okay, please review your partial fractions. Okay, so by doing that, we can now solve for the constants a and b by multiplying first the LCD, which is y plus 1. So we have 1 is equal to, multiplying this to this part, we have a y plus 1, then plus multiplying this term to this part, we have b y. Okay, then solve for the value of a and b. So let's try to equate this in terms of 0. So let the value of y is equal to -1, because if we let our y is equal to -1, then we may cancel this out and we can now solve for the value of our b. By doing that, we have 1 is equal to a times -1 plus 1, so this is just 0, plus b times -1. So our b is just equal to -1. And to solve for value of our a, then let's now let y is equal to 0. If y is equal to 0, then we can cancel this part out. Then 1 is equal to a times y is 0, so we have 0 plus 1 plus b times y is 0, or just 0. Then from here we have 1 times a is just a, so our a is just +1. And after getting the value of our a and b, we may now go back on our partial fractions and integrate this part instead of this one. Okay, so simply we have from here, by doing the partial fraction on our first part, this is the dy all over y squared plus y is just equal to 1. The value of our a is 1 all over y plus the value of our b is negative 1. So we have negative 1 all over y plus 1. So this is negative 1 all over y plus 1. Then this is dy. Right? So once again, we've solved this y's part by using the partial fraction or the rational integration. And then do not forget that we have also another part here, which is the integral of dx all over x. Okay, so by getting the integral of these terms, we have the integral of 1 over y, we have ln of y minus the integral of this is ln of y plus 1, then plus the integral of this is ln of x. Then our c is, let's make it a ln of c. Okay, so by getting the property of logarithm, or by using the property of logarithm, we have a ln of, since we have subtraction, then we have subtraction and addition, so we have ln of all positive must be in the numerator, xy all over, and the negative is our denominator, y plus 1. Yan is equal to ln of c. Okay, and by getting the exponential of this whole term, we have xy all over y plus 1 is equal to c. And this is now our general solution, or you can express this by what else, say multiplying both sides by y plus 1, so we have xy is equal to c y plus 1. You can also use this as our general solution. Okay, and since we have initial condition, by the way, we have y sub 0 is equal to 1, so we need to use this in order for us to get our particular solution. Okay, say let's use this first as our general solution. So we have, let me rewrite this, xy all over y plus 1 is equal to c. Okay, and from our initial condition, we have y sub 0 is equal to 1. So it only means that say y sub x is equal to 1, meaning this part here is 0, or you can rewrite this as y is equal to 1 and x is equal to 0. Okay, so that is the equivalent interpretation of this part. Y sub x is equal to 1, or y sub 0 is equal to 1, then we may use y is equal to 1 and x is equal to 0. Okay, so if x is equal to 0, then we have y, then 1 plus 1 is equal to z. So this part here is 0, therefore our c is just 0. Then the general solution is that our xy all over y plus 1 is just equal to 0. This is now our particular solution. For the given dE, x dy over dx plus y squared plus y. So once again, this is our particular solution.